Hello and welcome. This lesson is meant to help understand machine learning. And we're going to start off with a prompting question. How can we use sets of data to help us make predictions? Our agenda is as follows. We want to understand machine learning, think through regressions, also talk about intelligent applications, building intelligent applications. And our objectives are as follows. We want to analyze an intelligent application that makes predictions from data, create models that predict a continuous value price from an input features, tabulate and graph simulation results from parameter values that we select, and examine how to analyze performance of your predictive model and implement regressions. And so have a quick video. There will be no sound connected with this, but just kind of setting in motion kind of what we're going to be talking about today. I hope many of you all remember the film Back from the Future from the 80s. It was right when I was growing up and became a fan of movies. Unfortunately, I'm not going to be able to show it right now, but I think the key part that I want us to be able to look at is these new Nike shoes. This was a futuristic shoes that was developed, or the concept was kind of developed in the 80s. And I think if they were around today, how much could I sell these for? I think that's kind of the way that we want to be able to think about it. A quick hint, since technology was not developed in the 80s when the movie was done, there are actually people underneath the car who are strapping the shoes for Michael J. Fox. But we do know that Nike made these shoes back in 2006. And what we want to think about, what's the best way to come up with the future price for these? One way to look at it is the resale value. I know many of us out there are really big into gym shoes, basketball shoes, athletic gear. And so there are companies out there that go ahead and log this information on there. And so, as we can see, these shoes that lace themselves were last sold for $47,000, and we have an option to buy it either for $65,000 or $45,000, depending on how our bid goes. But I think what we want to go ahead and think about is, what do you think the buy and sell prices come from? Are we sure this is a good price? And I think the way we want to think about it is not necessarily about the shoe. I don't have enough money to buy a $45,000 or $50,000 shoe, but I think what we want to think about is, what makes this app so smart? How is it able to fluctuate between different prices in real time? And then in particular, what makes any app or machine smart? And again, how smart are they? I know we've all had the experience when we've tried to go ahead and Google something and it already tells us what we're looking for by popping up in the search bar. What happened there? And let me go ahead and start off by talking about kind of what my summer is. This was a summer fellowship that I had the opportunity to work with Stanford University. It's during the onslaught of the pandemic, the COVID-19 pandemic. So unfortunately, I wasn't able to be in person. I was working with a professor and a grad student, and I was able to study machine learning and analyzing different cases studies to answer the following questions. What is machine learning, and how is it helpful in everyday life? And as you can see from the image on your screen, we know machine learning affects nearly everything that we work with, from Amazon to Google, Fitbit, Uber, Glassdoor, Pandora, Netflix. It is very well used in our day. So let's talk about, what is it? So I'm gonna give you guys a few moments. Go ahead and pause the video as needed to imagine creating a new app. What type of prediction do you think you want to make? And how could you use data to help make a prediction? All right. As a math teacher, I am very much interested in how data actually works. So as we can go ahead and see right here, this is a graph of the Nike Mag Back to the Future shoe. And as we can start to see, we have the cost is going to be at the bottom, our resale purchase price. And on the y-axis, we have time, the number of months since its release date back in 2006. And the question I want us to answer or is how can this data help us make a prediction of how much to sell the shoes for? If I were to send you a pair of shoes to your house right now, how much would you sell them for? Would you keep them? Would you hold on for them? Or will they just continue to go down in price? And as we think about that, I think one thing I want us to be able to do now is look in terms of the concept of regression. In the mathematical context, regression deals with statistics. And what we want to think about is predicting outcomes. And so there's two places that we want to be able to start with. A scatter plot points that show the relationship between two sets of data with one variable on each axis. Often we look to observe and show the relationship between two numerical variables. And if the variables are correlated, the points will fall along a line or curve. And when the relationship between the correlated variables sketches a line, we call this the line of best fit. And as we can see right here, this goes to the CO2 emissions per person versus the GDP, the gross domestic product per capita. And we see we have a line of best fit where our input is a GDP per capita, so how much money is within a society, and our CO2 emissions. And we can see based upon the color coordinates, it's based upon Africa, the Americas, Asia, Europe, and Oceania. I believe that's how you say that. But I think the most important thing is from this data, we were able to create a line that fits to the data that represents how it's going to go ahead and grow or decrease. And so again, I apologize in this video. I'm not going to go ahead and play the videos, but I'll link this along with it. And so folks have opportunity to look at an introduction to linear regression. And then after looking at that video, I want you guys to go ahead and depending on your understanding of regressions, in particular linear regressions, we have, for some folks who are not familiar with it, we have two activities under the novice category, fitting lines and actual data versus predicted data. And then for folks who have a somewhat understanding, there is a simple linear regression task centered around NFL or sports leagues, NFL, MLB, and the NBA. Again, pause, take some time with that, and then come back and we can check in. And again, in terms of the graphing calculator that we're going to use an online graphing calculator that I am familiar with, and that's Desmos. And just to kind of understand how to be able to work with Desmos, we're going to go ahead and click on that link, and it's going to show us, not necessarily, it's going to create a linear regression for us, but it's going to give us some data and allow us to be able to work with it and show us how we go ahead and create our line of best fit. And so now, as we go ahead and begin to end part one, what we're going to look at is a regression case study, in particular, predicting houses prices. I'm going to ask you all in a moment to go ahead to Zillow.com. And if you want to go ahead and search a house and apartment building in your neighborhood, if you want to go ahead and use your actual information, go for it. But if you feel more comfortable looking just a location close to where you live, I think there's two things that I'm expecting folks to be able to record. One, the square feet. We want to denote that as your input, and the sales price and your output. And then from there, we're going to go ahead and use either Desmos or Google Sheets. And we're going to go ahead and attempt to be able to create a linear regression. Once we have the class, everyone's able to enter in all their data, we're going to go ahead and see if we can predict some prices using our new line of best fit. Welcome, folks. This is part two of machine learning. And to start us off, I want us to go ahead and examine the machine learning pipeline. We're going to start with data, and then ML means machine learning, and we're going to look at the machine learning method, and then hopefully that's going to go ahead and show us how does that yield intelligence. And so when we talk about first, what tasks are we trying to solve? And that is where our data needs to go ahead and become relevant for us. We have inputs and outputs, And I apologize, I'm going to move myself up just a little bit more so we can see the inputs we represent as our x values while the outputs represent our y value. From there, we have our method, and the type of question we want to answer there is, what machine learning method makes sense to us? Move myself again to the center. We have regressions, classifications, clustering, matrix factorization, deep learning. For us today, we're going to focus on the first one, regression, in particular, linear regressions. From there, we'll look at, well, how do we go ahead and build out intelligence? Again, what tasks are we trying to solve? And how do we measure the effectiveness of our model? In terms of our output, our Y value, the best guess of our future observation. And so, this is an opportunity for us to go back to our regression case study, predicting housing prices. We came up with our linear regression at the end of part one. Now what we want to know is how do we know it was actually a good prediction? So through decimals, along with our regression line, what we want to be able to do is, again, determine the housing prices with 300 square feet, 800 square feet, 1,000 square feet, 2,500 square feet, and 30,000 square feet based upon our regression model. How can we determine how well we made our prediction without actually knowing the future? And the way we want to go ahead and do that is we want to actually stimulate predictions. We do this by removing some housing data known as a test data set. We want to fit the model on the remaining data set, so create a line of best fit, our regression line. And we want to see is the information that we remove, are we able to predict it from the new regression line? And we evaluate how close we were able to do that through accuracy, how accurate the model was with the full data set. So a way to think about this is training and test data set. Training data set is randomly subset of total numbers of examples used to create a linear model regression, while we take the test data set and we omit it. We don't use it. And that's to be able to compare how effective the linear regression model is. So we'll use the training data set to see if we're able to create the test data set, or how closely does the test data set align to our regression model. And now the process that you all are going to go ahead and do right now is, what tasks are we trying to solve? We're going to be working with the stock market, agricultural yields, medical infrastructure, and look at the sports team, the NFL. And based upon that, you'll be able to be in a group with you and a few other classmates. Within groups, you will be given a data set based on the selected topics with the goal of plotting the data and applying a linear regression. Again, we need to specify our input outputs, build our linear regression, simulate our predictions by creating training and data sets, and then evaluating our model accuracy with the full data set. And then finally, from there, you'll have opportunity to report back, reveal the information that you found, and discuss and extend this information to the whole class. I'm expecting folks to make a visual representation. I use Adobe Spark to be able to go ahead and make this poster based upon machine learning, where we'll use one of those 4 areas that we decided to work with to help us understand what's going on. I know this was a short introduction to machine learning. In class, we'll spend a lot more time going into this in more detail, but just wanted to give today an overall structure of what we're expected to create. Thank you and have a great day.